Now, for today's class, because I couldn't project this, but at least for as many that joined the class, they will have a show. Okay. Okay. Now, today we will start with understanding relationship between process condition So understanding relationship between process conditions and product optimization using Factorial, composite, and Taguchi design. This is not part of the exam. This is just more like a software, learning software. So, but for today, I will only introduce you to Factorial design, composite, and Taguchi design. And by next week, you come with your laptop and we start. Because if I start with you now, you may not understand. But I need to establish the foundational knowledge about this. And if I were you, even after this class, I will advise that you have the video of this lecture. So, I mean, for your own personal development, because these people pay heavily for this to learn some of these softwares. So learning it now is an opportunity for you. And most of the company, they require people to understand DOE, that's design of experiment, because they use it most of the time for quality control, product development, and parameter optimization. As simple as it is, some people are getting job. At least I've seen one or two job applications out there where they require that all you need to know is just DOE. And if you know it before, it's an opportunity to upscale and to know more about it. I've been using it for the past 8 years, and I have close to 25 published papers on this alone. So we try as much as possible to use different real life scenario on this. It will not be theory, but today will be theory, at least to open up what Factorial design or design of experiment is all about. Let me start by saying this. Assuming you want to cook rice, I think I always use rice as an example. There are different parameters we use by the time you want to cook rice, right? Part of it is if you are using induction cooker, for example. One of the parameters is what? We use temperature, right? We use power, right? And which other one? Rice to water ratio, right? These are the parameters, right? But don't forget that for those parameters we are using, there will always be an optimal value, and time also, cooking time also, making 4 parameters. So out of all the parameters, you discover that there will be a particular temperature that will give you a better and quality rice. There will be a better time for cooking. If you spend less than that time, your rice may be uncooked. Exactly. So those 3 or 4 parameters you are dealing with, we can also use it in any experiment, especially in the lab or in any production process. Because you can actually play around those parameters to check which one has the best and optimal design. This is an example. Let's say you have, so I just want to start from this. You want to cook rice, right? Some of the parameters for cooking rice, 1, if you are using, let's say, induction cooker, maybe temperature. 2, cooking time, right? 3, let's say rice to water ratio, right? Then 4, at times salt is very important too. Amount of salt. Which other parameters do you use? I'm talking of white rice now. So I want to use the example you know before we move to the real experiment. Which other parameters in cooking rice? Or you only buy rice from McDonald's, you don't cook? Pattern. I know you're a foodie here. Which one?
Depend on the water level.
Water level. I think we've mentioned it here. Rice to water ratio. Okay, let's just assume we have these 4 parameters.
The pressure.
Pressure, that's if you are using pressure cooker. Let's assume that it's not okay. Let's assume we are using pressure cooker. Pressure. For temperature, there will always be for every what's the name? Every induction cooker or every cooker, whatever it is, there will always be temperature range, right? Most times maybe from, let's just say 50 to let's say 120 degrees, for example, right? Cooking time, we don't know. Let's just say your cooking time can vary from 15 minutes to 1 hour, right? Let's just say 60 minutes. Rice to water ratio, let's say we have either 1:10 to 1, let's say 20. Just as an example, right? Then, amount of salt. Let's assume that depending on what you have, maybe the amount of salt is just, amount of salt is even an uncontrollable factor. Let's not consider this because the amount of salt will depend on our what? The rice. So let's kick this one out. So we have this factor, we have this factor, we have this factor. So we have 4 factors now. Now, in design of experiments, we can work around all these parameters to get an optimal texture for rice. Okay, now, in cooking rice, for example, what are some of the quality characteristics you look into when cooking rice? I'm using this as an example for you to understand. Then we'll move to the experiment. What are different things you look into when you are cooking rice? Saya. Okay, Krish. What are those things you look into? You look at when cooking rice to determine the quality of your rice, for example?
Again, it's if I want some loose rice, then I will add more water. And if I want some...
Okay, that's texture. That texture is there, right? Which other one? No, boiling time is a parameter.
Size of the type of the rice, whether it's long grain or short grain.
We are not considering that. You are making it complex. So let's just say the texture, the only quality characteristic we are looking at is texture because it's white rice. Stickiness. It's this texture. It's this texture. Let's just say texture is our what? Is what you are looking for. So when you please, there's no better way to explain design of experiment than this. So your quality characteristic, we call it what? Response. In design of experiment. And all these variables you are manipulating here, you are playing around, is what you call parameters. Exactly. So now, what we want to do is that we want to play around these parameters to get the best what? Texture. Exactly. It's more or less like if all of us here, we play around these parameters here, we don't get the same quality of the rice. Please listen and listen well. If all of us here, we play around all these parameters, I give you different parameters, all of you, right? If you cook this rice, you will not have the same quality characteristics. There will be worse and there will be the best of the rice. Exactly. The best of the rice is what we call optimal what? Condition. The condition or the parameters at which you get the best response is what we call optimal what? Condition. That is what we call optimization. You are optimizing something. Let's now give an example. Maybe in industrial level. Let's assume that we want to, which process is that? Which process is that? Okay, let's look at wastewater treatment, for example. In wastewater treatment, there are different parameters we can use in wastewater treatment. Most times, okay, let's assume that we have a system or a bioreactor that has pressure, right? That has temperature. There are, okay, which other thing? So, or let's not use biochemical process. Let's use extraction process. Let's use cold press, because we are in separation class now. You know cold press? If you want to press out juice. If you want to press out juice, there are different parameters. The first one is the what? Juicing time. That's one. The second one is the what? Which other one? Your pressure. Which is it? The pressure we want to? How do we? I think rotation speed. The rate at which this thing is rotating. And let's say we have two parameters, for example. The pressure we are applying and the time we spend inside that. Please don't disturb us, please. This is very important. Now, we have two parameters. And what we want to do is that our response will be what? Yield. Because we want more of the juice. Right? Now, if you want to optimize that process, for example, we'll now find pressing time. Yeah, that's pressure. Pressing time. Okay, let's start from the pressing time for now is what? We are looking into the pressing time to be between 15 to 30 minutes. Right? And which other one? Which
Pressure.
the pressure, that is the pressure we are applying. Or the rotating speed of that, whatever. Let's say we have from 200 to 600. And these are parameters, right? Then our response will be what? Yield. That is the yield of the juice, right? Uh-huh. So how much of the juice can we get from this what? From this apple, right? Now for this kind of experiment, what we do is that we have the software will give us at iteration in terms of tests. Test 1, 2, 3, 4, 5, and so on and so forth. So the first one, maybe we have time, right? And we have rotation, right? And our response is the what? Is the yield. Let's say it's in percentage. So maybe the first time, the software will generate different time within this range, right? It can generate, let's say 15, 10, sorry, not 10, 15, 25, 16, 30, and so on and so forth. It will generate rotational speed also. It will generate it on its own. 200, 250, 600, 550, and so on and so forth. And the first run, please listen and listen well. The first run, you will test it. Put your apple, put it inside, right? And at the end of the day, get the yield. What is the yield we want? So it means that it will be the same mass of the apple. You get the yield here, maybe 20%. You check again. You using pressing time of 25 minutes. You check again, right? You get your yield. At the end of the day, when you look at this one, you discover that from all this iteration, you have the one with the best yield, right? Let's say this one is giving us 80% yield. So it means this one is the optimal condition of pressing. So this is applied to different applications. So take for instance, in that your company, you deal with different parameters, right? You check the lower range that you need, you can set it to. You check the highest range, right? For different parameters. And you look around and say, okay, what is the quality characteristic you are looking forward to? You cannot make it in iteration. You see, you have different quality parameters. From there, you can say, okay, if you have been using, because now, in quality control, maybe there is a particular settings your supervisor or production manager has already given to you. You can actually use design of experiment to get better optimal condition. If let's say later, previously, this is the condition your your boss gave to you. But with DOE, you can get a better one and get a better result. So you can just, okay, this is a better one. And this is how company gets better, profit than others. Imagine this is 40%. A company A is using this, and a company B is using this. And let's say we have 90% for this. A company C is using this. The same process. So it means company C will get more what? Yield, and even the gain, the profits, they will have more profits than others, despite the fact that they are doing the same business, right? Using the same quantity, using the same machine, but at the end of the day, they are having better profits. So this is where DOE comes in. You can use it in different life scenarios, different experiments to arrive at what? Better yield. All the GSK formulators, this is what they use. They use this one in product formulation. And this is the secret of chemical engineers. So this is just the foundation of what? Of optimization. So, and at the end of the day, you have how many? You can have just 20 runs, 30 runs. But don't forget that 20 runs, 30 runs is not enough. If you want to take a step further, you can go into simulation. Maybe multi-color simulation, artificial neural network using MATLAB, and you can use Python, you can use any other thing to generate other conditions here based on this experimental condition. You can generate up to about 1 million conditions or maybe 1,000 conditions apart from what you have in the lab. But this one is just the experimental run that will give rise to what? Better condition. Do you understand what I'm trying to say now? So this is just a general understanding of DOE. So now, design of experiment is a powerful tool. So today, I will only give you the background of DOE. This is not part of the exam. This is just an additional knowledge for you. For some of you, you may not understand what I'm doing now, but you will thank me later. It may not be 2 years, it may not be 3 years, it may be 4 years after. You will remember this, but keep this video. You will need it. So, design of experiment is a powerful tool for systematically studying and optimizing processes. Optimizing processes by carefully planning experiments, analyzing data, and interpreting results. Engineers and scientists can make informed decisions to improve quality, reduce costs, and innovate effectively. Imagine the cold press of juice now. Different companies can use the same juice and the rest like that, and at the end of the day, they may not get the same quality. And the secret of it is what? The secret of this is what? The design of experiment. As simple as this is, this one can cost a company a lot of, It can cost a lot just because of this. And that is where R&D, research and development, comes in. So by the time you want to apply to a particular company that deals with formulation, and they tell you, how can you add to this company? Or what did you gain from your master's program that will be of help to us? So if it's a formulation company where they are producing something, you can just tell them that, okay, if I have this opportunity maybe to work in your R&D, I notice that you have a process condition already. We look into how we can optimize the process for better yield. And we ask you for that. How do you do that? And the example is, during my master's, we made use of DOE, using different statistical tools and different tools. And they will ask you more, because most of them don't know this. They will ask you more, how did you do it? Okay, for example, in the production of yogurt, for example, we have different parameters we consider. And we have the quality characteristics we are looking forward to. You can ask them, what are some of the quality characteristics you look forward to when you in the production of yogurt. They will tell you, oh, we want this, we want that. Okay. Now, if you want a certain texture or a certain taste, then it means we need to find a parameter interaction that will give us a better product. And this is where design of experiment comes in. Just blow all those grammar. With it, not that you are just blowing grammar, you are talking with what? With facts. And with this, you will know that, oh, this person has something to offer. I'm telling you, many companies are using this, especially in this UK. At least I've seen one job like that online when I first came here. DOE. And they are paying around 30-something thousand just for DOE experts alone. And you don't need to know much. It's very simple. So, why do we conduct DOE? One, to understand the relationship between the input factor and the output response. So now we are looking towards the relationship, like in cooking rice now. We want to see what is the interaction between the cooking time and your temperature. What is the interaction between the cooking time and pressure? What is the interaction between the cooking time and, let's say, which other one? Rice to water ratio. So by the time you understand the interaction between those parameters, then you understand your process. So understanding the process has nothing to do with how this process flow. No. The most important thing is terms of formulation. We use this one in formulation. So to understand the interaction between each parameter, it's just like human being. If I want to deal with you now, there are some parameters about you. Maybe in terms of anger, in terms of how you eat, in terms of how you control yourself, in terms of money. You know, those are parameters. So I need to understand you very well before I can move closer to you. So the same is applicable to every process you are dealing with. You need to understand all the parameters and the ranges of that parameters. Why are you sitting separately today? Are you fighting? Don't fight. If you fight Mukunda, you're a man. Don't fight her. Right? You're a man. So you need to understand all our parameters before you can work together. So that is the same thing applicable to the processing condition here. Then it's used to optimize processes or products. You see, optimization is just a big word. So optimize means you want to enhance, you want to improve, you want to make better, right? We have a process before for cooking rice, but we want to have different iteration and try different formulation. Do you understand? It's more or less like if you're a chef, you try this today, you taste, oh, this makes sense. You try it today, this makes sense. But what they do is just try and error. Even if you're a chef, you can use this one application. Even to improve your products. You just use it small, and hard. If you have a process, just let me know. We design our experiment and you have a better product. So that is the second thing. Then the second thing is that to minimize variability and improve quality. That is to maintain consistency. When you know a particular temperature that will give you a better yield, you know a particular rice to water ratio that will give you a better yield, you know all the parameters you need that will give you a better yield, there'll be less of variation. Not that you will cook rice today and it will become hard like my hand, and tomorrow you will cook one, it will be soft. No, that is inconsistency. It's more or less like this water. If today you drink the water and it's salty, tomorrow you drink it and it seems as if there is salt inside, next tomorrow it's neutral, you will not buy this water again. So to maintain consistency, DOE is very important. Then the next one is that where is DOE applied? One, it is applied in new product design and development. When you don't know, you are designing a new product. Let's say new yogurt, new beverages, new this and that and that. So you can use DOE. And then for product improvement, you have a product already, but you want to improve upon it, maybe for better yield or for better quality characteristics, you can actually use DOE. And the next one is that in process improvement in manufacturing also. Most of the time in manufacturing, they use Taguchi. So I will tell you later. So we don't. 7 classes is not enough deal with this, but I will try as much as possible in 3 classes. I will deal with the fundamental of this. Now, parameter effects and product quality. What is the effect of different parameters and the products we get? And the last one is using scientific research. I told you I published more than 30 articles on this. So you can use in scientific research also. My students, you won't escape that for your project. But I will teach you everything you need to know, right? So it's used in what? Scientific research also. If you are my student, you are very fortunate. I've taught a lot of things to you. So now, key concepts in process condition and product optimization. Please make sure you understand what I'm teaching you now, because by the time we start the real software, whatever, you will understand it better. Now, the first factor is what we call the first concept is what we call factor. Factor, very simple. Parameters. What are the parameters in cooking rice? Temperature, pressure. We call it factor. It's either you call it factor, or you call it variables, or you call it parameters. Exactly. So the next one is the levels. Level is specific value or setting of a factor. Now, what is the meaning of level? You remember that if you are involved in setting, maybe in industrial setting, you always set something. Set temperature, set pressure, set this. They are always level, lower level, the highest level. In those who normally come for quality control, they will tell you, okay, please, if you are an operator in a particular company, don't go above this and don't go below this, right? So the one that should not go below is the lowest level. The higher level is the what? Upper limit. You have lower limit and upper limit. That's what's called level. So we use this one also. Then responses. Response is very simple. What quality are you looking for? Right? Is it texture you are looking for? Is it just depending on what you are dealing with? What texture? Sorry, what quality are you looking for? The main effect and interaction. Main effect, the effect of a single factor on the response. Now, main effect is this. Why are you laughing? Why? You are overthinking. Why are you thinking about? Just calm down. Think about this class now. Think about what you later do. It's cute, right? So, now let me tell you what you are thinking. So, main effect now. Main effect is the effect of a single factor on the response. Now, we have cooking time, right? We have rice to water ratio. We have temperature. So, each of these factors, they have contribution, each. Not in total now, not in interaction now. So, for example now, the cooking time has its own contribution to the texture, right? Rice to water ratio has its own contribution to the rice texture. Fiber, temperature has its own contribution to the texture. That is the individual effects, you understand, on the responses is what you call main effects. Just like you have in a country, the contribution of each of us individually is a main effect. Do you understand? But interaction effect is the contribution of when cooking rice, cooking time, join with rice to water ratio, with temperature. We join our hands together for this. That is what we call interaction. That is the reason why I put you into different groups. Because I want us to bond together to get a better result. So now, in design of experiment, we have main effect. That is the effect of a single factor on the responses. And you have the interaction effect. That is the effect of one factor depending on another one on the response. Do you understand that? So that is, it's more or less like a single person. When you have, this is UK. If you come in as a single person, right? So you are the one that take care of food. You take care of water bill. You take care of council tax. If you have council tax anyway. You take care of light bill. You take care of which other one? What is it? You take care of the rent, right? That is as individual. But if you have a partner, Maybe you come as husband and wife. Mukunda, you understand? So maybe Mukunda, just use as an example. Until you leave this class, I will continue to use you as an example. Don't worry, you are good. Malini, are you good?
Yeah.
So let's say Mukunda, as a man, you take care of what do you take care as a man? Of rent. You take care of rent. And sorry, Priyanka, Malini, I'm not talking about Malini, sorry, Priyanka, you take care of water bill, right? Let's say you have another friend, you understand? That one take care of the light bill. You can work together interactively. The same thing applicable to design of experiment. By the time, we are not talking about individual contribution now. We are talking about the effect of 3 or 4 contributions to a particular cause. You will discover that by the time you contribute, maybe each and every one of you, your life will be easy in this country, right? So now you don't need to think about paying light bill, Mukunda. Priyanka, you don't need to think about paying rent because Mukunda will take care of that. Do you understand what I'm saying now? So the same thing applicable to the design of experiments. Exactly now. So all the factors, they work together. So in cooking rice, it's not about time alone. The cooking time alone. Because most times we discover that after cooking rice, we discover that we didn't get what we needed. And you take just one factor as the victim. That, this is the factor. It's because the water is too much. It may not be because of water. It may be because of the water, of the temperature. Do you understand what I'm saying now? So the same thing applicable to every processes. One process cannot be the reason why what's the name? One factor cannot be the reason why a process fails. You have to look at all the individual factors. And this is where design of experiments come in. We just call it design of experiment. We can call it quality control also. So that's that about that. Now, key concept in process condition. Please, this is very, very important. Now, experimental unit. The smallest division of experimental material such that any 2 units can receive different treatment. Experimental unit is when you have different units. The first experiment, second experiment, third experiment. Let's say, like in iteration, maybe the first experiment you used cooking time of 15 minutes. Rice to water ratio, maybe 1:10, right? Temperature of 20. Sorry, temperature of 80. That is one experiment. The second experiment, change the parameter again. That's the experimental unit. Then we call something replication. Replication is that instead of the first experiment, instead of conducting it once, you can do it 2 times or 3 times. In case the first one you did is not correct, maybe there is a particular variation, you can use the same factor or the same role, on the same row, the same parameters. You do it 3 times just for you to be sure that, okay, the responses you are getting are the correct response. That's what we call replication. That is repeating experiments under identical condition to estimate variability. That is a variation. And then we have randomization. That is randomly assigned treatment to experiment unit. You know something? Just leave this one. I don't want to confuse it further. Then blocking. Just leave this one, right? We'll come back to this later. Type of processes and product design in design of experiment. For this class, I will try. If you can consider full factorial design or fractional factorial design. Please, this is just English. All this is inside that word, software, right? So we determine full factorial design and we determine fractional factorial design. Now, full factorial design, we only use this one for screening method, screening purpose. Let's take, for example, in a process, there may be up to about 20 parameters. You can't optimize all. Do you understand? But for the first thing, before you start optimization at all, the first thing you need to do is to screen some parameters out, the one that is not important. Because not all parameters that is needed in, like you remember I use salt, amount of salt too, I screen it out. So the purpose of factorial design is that every of the parameters that are not important is screened out. And the one that has higher contribution, you understand? For example now, in cooking rice now, there are 3 basic factors with higher contribution to the texture of your rice. Time, the temperature, and the water to what? Salt ratio. Now, if you want to consider other factors too, maybe the psychology of the person that is cooking. Because let's say everything is okay. You use the same temperature, normal this, and maybe while you are cooking. So for some of you that like burning our food, I know there are some people here that you like, no matter what you cook, you always burn the pots. That one is not the fault of the process. It's a human error.
That can be part of the process.
No, what I'm saying is that one, you understand, can be part of the factor, but we can screen it out. That's what I'm talking about. Do you understand? So for every process, there are thousands of parameters. But you need to look at the parameters that have the highest contribution. Because most of the time when I use Taguchi in my research, I discover that you know what it will do? It will give me all the factors. And it will rank all the factors, 1, 2, 3. And will give me the one that has the highest contribution, 50%, 20%, 30%. So anything that is below 30%, extract it out. So the one with higher contribution, I know that is the one that is affecting my process. This is where factorial design comes in. Both of them, they are used as what? As screening method. All this you are saying is just Jack Robinson. So the main thing is what it is being used for. Exactly. So then, type of processes and product design in DOA. So once you get to a company and you start working and they need people to teach them this, just call me or teach them and they will understand. I will teach them based on the process. I will have something good. Because most of the time in graduate programs, you need this method, you need this understanding before you can get to the process, the process itself. So now, we have type of process and product design. Okay, I've made mention of this. Just forget about this. We have randomized design, Latin, square design, Taguchi method. You don't need to know all, right? I didn't know all of them. But the one I knew it very well. So I know Taguchi very well. Most of the time, this Taguchi is used for, imagine when you design your experiment, imagine you have up to 70 experiments. You know, they are too much for you. So, and it means you will use more materials to conduct that experiment. But imagine you are dealing with costly materials and you need to cut down the number of runs. The number of experiments. What you do, you can actually use Taguchi. Taguchi is more useful in manufacturing because you don't need more experiments to arrive at optimal condition. So even though you have a particular company that maybe you are dealing with something, you can actually use Taguchi. With 9 runs, 8 runs, you can get the optimal condition and give to the company, okay, this is better than the one we have been using before. So that is that amount. Oh, so for Taguchi, these are different examples. These are some of my published papers on that. Then type of process. So for this class, we consider, what's wrong with you? We consider Taguchi methods and response surface methodology, because this is the most popular one. Response surface methodology. I know many of you have come across this before. So a collection of mathematical and statistical techniques for modeling and analyzing problems in which your response is influenced by several variables. One response, political and statistics, is affected by what? Different factors or parameters. So purpose is to optimize the process by finding the best what? Factor level. Like for example, in cooking rice now, we optimize the process to get the best cooking condition. And that is what we call, is it racine? Is it recipe or what is this? Recipe. Recipe. That's what you call recipe, right? I want to give you recipe. It's also for this. So that's that about that. So these are some of my in separation process. Some of the papers I publish in separation process. I publish in the separation processes, water treatment, and the lots like that. So steps in designing. This is very important. Step in designing. So when I say it's important, don't read this for the exam, right? I think I'm good now. Because you're always the one that was always concerned. So the first one is that define the objective. State the purpose of the experiment. Why are you conducting that experiment? You go to a company and you discover that the reason why you are conducting the experiment is that the owner of the company is telling you that, oh, you discover that we have more, what's the name? We have more batches of production, but we are getting lesser profits. So it means the reason why you are conducting that experiment is because you want to cut costs of production and increase profit. That's one. Secondly, it may be maybe they discover that in the what's the name? Maybe in beverages, the production of beverages and the rest like that, the taste is not better, it's not as good as from other company. How can we have better taste? Well, that's one reason again. That is product enhancement. Exactly. So a lot like that. Then another reason is maybe you want to try, you'll be using another component, or you want to introduce a new component into your system and see what will be the effect. Maybe that's the reason. So it means the first thing to do is to set out or define an objective. Then the second one is identify factors and responses. What are the factors you need? Okay, my voice, right? Don't worry. They are listening to me. So the next one is identify the what? The factors and responses. That is, what are the factors that you need in cooking rice? We've mentioned that. That's what I use as an example, right? And what are the responses? What do you want to get out of it? Is it the texture? Is it the color? Is this and that and that? Those are the responses. And the next one is that choose the experimental design. Do you want to use Taguchi method? Do you want to use response surface methodology? If you want to use Taguchi method, maybe the reason why is because you want to arrive at optimal condition at a faster rate. Maybe with nylons, you want to get the optimal condition. Or maybe you are dealing with costly materials and you don't want to spend more materials for you to determine the optimal condition. So that's that and all that. Then replicate or randomize. Replicate is that instead of conducting experiment once, you can do it 3 times. Just know whether what you do. For example, now you have a recipe, for example, and you try that recipe, give you something. Then it's better you try it also. You try it also. You try it also. That's what called replicates. Such that it's the same condition of cooking, but we want to see is there any variation in what we get. You understand that? And before you can get the variation, you need to get maybe the standard error between the 4 of it. Don't worry, by the time we get to the experimental part, maybe you understand better. But don't worry, we have an experiment I want us to deal with later. Then conduct the experiment. That is, go to the lab or to your kitchen or to your process unit, production unit, separation unit, and so on and so forth. So then you analyze data. This is the most important part. Most people know how to use DOE, but only 20% know how to analyze the data. I mean, analyze the data to letter. This one to this one to this. The reason why this one is increasing, this one is reducing is this. Okay, it means if you increase more of the temperature, at the end of the day, the rice will become modular. And instead of forming a rice, you will form, is it rooty or what? Is it rooty or you form something else. Do you understand what I mean? So that's that. Then some people know how to analyze the data, but interpreting the data is very important. You see, the way I'm talking to you now is because I've worked with this. So interpretation is very easy. I can use different method or different scenario to explain to you That is interpretation. How do you interpret? Okay, when we increase temperature, pressure reduces, blah blah blah. That's interpretation. That is that about that. Then after interpretation is implementation of our finding. At the end of the day, we discover that the optimal condition in the production of a popcorn is this. Or the optimal condition in wastewater treatment is this. The optimal condition in the extraction of protein from avocado seed is this. Then, with that condition, we can actually replicate it into industrial scale, into full scale. And you can have a big plant with that same. You have a big plant that will tailor towards that process condition. Such that when you see that big plant, maybe during the process of optimization, you discover that the best temperature is 90 degrees. So by the time you want to design that reactor, it means the knob you will see there will be between, let's say, 85 and 95, because we already discovered the optimal condition right from the design stage. Exactly. Now, analysis of the data. There are different things we can use in the analysis of data. We have ANOVA. I think some of you are familiar with ANOVA, but ANOVA is more than what you think. It's more than what you think. Then we have sum of squared. We have degree of freedom. We have mean squared. We have F ratio, regression analysis, residual analysis. Let me just be sincere with you. Design of experiment is not something that you understand in a day. You keep on building upon it, but it's better you start now, such that you keep on building upon it. Before I told you that different software you need to learn, you remember? The life cycle assessment and the rest. This is one of it, and this is what we are doing in class. Maybe next year, if you have money and we're able to get what's the name? Get a license for Sigma Pro. Maybe I will teach them next year how to use what's the name? Sigma Pro for life cycle assessment and technical modeling. To you, it may not make sense to you now, but later you understand what I'm saying. I know some of you will call me. I know what I'm saying. So that's the kind of that. So that was the reason why I say you subscribe, so that if I have a video, only 4 people subscribe. Don't worry, you think you are doing it. You're not doing it. It's yourself. Then now, clearly divine objective. So we mentioned Brata. Are you see eating that fermented? It's really affecting you.
Fermented Dorito.
Fermented what?
Dorito.
I'm not interested in talking in it.
So don't worry, you'll be our supplier of fermented. You don't drink alcohol. Yeah. Fermented pizza. But you can have that company. We can design the process for you. The fermented pizza. Fermentation time will be
We
there.
are planning to open a shop. So if
You can open it here, we buy from you.
yeah.
That is if it will not give us running stomach.
If you want, we can like make your partner.
Please listen though. So we have different softwares. Please, it's okay. We have different softwares for DOE. We have Minitab. We have Design Experts. You can use GMP and you can use what? Python. How many of us know how to use Python? How many?
Python?
Python, yeah.
We're just learning Python.
Who is teaching you? Jeff. Please know it very well. You don't know what you have.
We are not learning, we are just making our project in there.
Exactly.
But please, one thing about it is this. Most of the time, when you have gold, you don't know that gold is beside you. Right? As a student here, there are a lot of things you can learn. Right? What happened?
Good.
So there are a lot of things you can learn here. To you, what we are teaching you may not make sense to you now. But when you get outside that, you want to come back. You already graduated, right? And you will call me, hello, hola. And please, I want to, that DOE, whatever. I will not even answer you. That is if you are not serious in my class before. I will ask you to go and learn it and pay. So by the time you pay 1,000 or 3,000 or 4,000 pounds to learn it, you will will sit tight. So all you are learning now, for the one Jeff is teaching you on Python, please make sure you understand it very well. If you don't understand, go to him, he will teach you. Then all this design of experiment, make sure you continue. I know you are laughing now, don't worry. You come back to me and I will collect big money from you now. And then you have graduated.
I'm sorry.
No, don't be sorry. So we have Militar. How many of you or of us know Militar?
No.
You don't know Militar?
No.
Do like this. So you don't know Militar?
No.
Mukunda? You don't know Militar?
He's the founder of
Ali.
Ali? Have you come across Militar before?
No.
No, I agree like this. So the next one is design expert. Anyway, that's why you are here. And we have GMP. I hate this software. GMP. It's too complex.
Python in these.
And we have Python.
Python and Jupyter.
Yeah, let's go with this.
Okay, you know GMP?
No.
You know Python?
Yeah, no Python
Design
only.
expert.
Do you know design expert?
No.
You know it. So for this class, hello, please listen. We will limit ourselves to design expert and Minitab. So if you are able to install design expert inside your laptop, we'll use design expert. And if it is, what's the name? Minitab. Minitab is easy to install than design expert. But I will try as much as possible to have this for you, and we'll see what we can do. So, conducting factorial design. So this is where a real thing happens. So let me just teach you the theory now and later. So I've divided. So this one is using Minitab. So even without coming to class, you can even try your hand on it. You have what? Launch Minitab. So I've made everything simple for you now. Open a new worksheet by clicking new here and with you.
Which one is like best to use?
Like what?
Which one is best to use it on?
For me, design expert is best for research purpose.
Expert.
Design expert.
Okay. Design expert.
Expert, yeah. But Minitab is better for industrial purpose. But to me, I use it for different purposes. For example, Minitab, I use it for Taguchi. Taguchi optimization.
No. Taguchi is also any software?
It's not software.
It's a method, right?
It's a method.
We can use it any of these.
Then you can use it for in design expert, but I don't like it in design expert. But it's better on Minitab. But response surface methodology is better on design expert.
Design expert.
So I've used both before. But Python, I've not used Python before, but my friend uses it. Most of the time, I give it to him to just run it for me. I don't have the brain to start learning that again. You understand? So you have what? Design expert and what? Minitab. If you know that for this level is good. Then Python, once you know the fundamental of Python, all you need from Python is just to understand how to navigate and the rest like that. The rest you can learn it on YouTube and the rest like that.
Actually, we are using the Jupyter notebook for using the Python, so I think we can use this on that. For that purpose.
It depends on what you are dealing with.
You only have to identify some kind of fault in that project. So you are only using for this one.
Like I said, it depends on the objective. You understand? Because most of the time, one of the problem with this is that most of the time, before I can tell you what to use, you need to tell me the problem you are dealing with. I've handled a lot of projects, PhD projects, for people. When I was in Malaysia, someone will come from electrical, right? You can use this for electrical too. Someone will come from mechanical, you can use that. So that was when we were trying to make money that time. So you design the process for them. And some of them is after they have finished their PhD. And the external examiner rubbish their work. And they come back, oh, how do we do this? Then you need to start over again. Then they give them one more year, extra year, just to finish that. So and that is the reason why all this is you need it at the onset of your project than after. Exactly. So, 5, new, the Minitab project. Then, divide the divide the factorial design and so on. And please wait. For Minitab, there is a free version online, but I have a full version that I can share with you. So I'll share with you. I'll install it for you here in class, but I won't give you the file because the file is the number of what's the name? The number of installation matters to me, because once all the installation is only for this class, at the end of the day, if you have a laptop, how many of us have a laptop? Laptop? Jyoti, you have your laptop, right? Okay, good. So please, next week when you are coming, come with your laptop. Maybe we use Minitab instead of
I have installed that software in the pen drive. I'll give it to you. I have mailed you.
No, you know something? I was coming all the way from what's the name? Wardroom. So my laptop, everything is inside my office. But don't worry, next week that's when you need it most. So now, in the dialog box, type of design, you choose the type of design. Then you click what number of factors, the parameters you are dealing with. So divide the factors and the label. In fact, without teaching you, you can actually follow this too, depending on the project you are dealing with. Then randomize and create experimental run, hard response, analyze the data, and so on and so forth. Review the results. So let me give you an example of some of the results I got. Let me see online if I save it. So look at this manuscript. Please listen. For this manuscript, I used, I think I published this in 2018. So for this, we used that's Journal of Analytical Science and Technology. That's Springer. Application of orthogonal optimization. Orthogonal optimization is the same thing as Taguchi. And feedback propagation model in microwave extraction of natural antioxidant from tropical white pepper. This is part of my. See this result. Please stop talking. So see this result. So this using Minitab, but I think this one is not. No, this is not a detail enough. Come in, please. Is there any issue? No. Are you sure? No. See, this is another one. Food processing and preservation. Investigating the microwave parameters correlating effect on total recovery of bioactive alkaloid from system leaf using so I use orthogonal matrix here and artificial neural network. See, you will leave that prepare time. You are disturbing my class. And if you call me, if you want this later, you see what I will do this for you. So for this one now, I use orthogonal and artificial neural network. Artificial neural network using MATLAB and orthogonal using what? Using Minitab for this. I will look at this result. Say this is ANN, right? You've seen it before, Taiba? Yeah. Okay. So these are the results you have seen. This is the result from the software. Then this is training. This is all these are from Minitab. This is from Minitab. The integration of Minitab and the artificial neural network. All these are very, very simple, not difficult. So, and if you know it now, it will be easy for you. You know now, for your masters, it's easy for you to learn a lot of things. But once you become a PhD student, you are on your own. You have to learn things by yourself. Your supervisor will only guide you, not teach you. You have to learn it by yourself. So all this side of by the time you start your PhD, that's when you know what is it. So whatever knowledge you need to gain from now, it's better you gain that. Exactly. So that is that about that. So these are just the application, how we can use it. So let's see if there is something more here. So by next week, we should start. See, these are some of the results. That is using design. The reason why I like Design Expert, do you know that? Is because it gives you colorful graphs. Yeah. So it gives you colorful graphs. Do you know that this thing?
You can use this one in CFD modeling.
You say what?
CFD modeling also gives us.
CFD modeling.
And CFD or something.
And do you know this? These results I think there's one of the results we published in what's the name of this? Royal Society of something, Factor. And the result is an industrial project. And all this, you have to break it down to those industrialists and make them understand what it's all about. It's very, very simple. Let me just be sincere with you. And the truth of the matter is that people you see in high-ranking places, you think they are more intelligent, they are better than you. They are using small things. No, they are using small knowledge to make money. That's what I'm saying. They come to your office, they do just small thing now. It doesn't take them anything, and they solve all the problem. And they start from now. So now, some of you that have been talking to you about learning different things, is an example of things you need to learn. So by next week, we start in details on this. So please make sure you come with your laptop. Then if you have any process you are dealing with, I can solve it for you. We can discuss about that.
Thank you.
You saw what?
Thank you.
So that I will make sure I record next week class. And next week class, I will list it on YouTube so that it will not, because some people are looking for it. So it will only be applicable to. But if I were you, I will download it and keep it.
What's the name of the channel?
You say what?
What's the name of the channel?
Is there on your this thing? Is there on your portal? Yes. So this is a hand. So for the first one, is just to teach you how to use for step by step on response surface methodology. So whatever we do next week, we follow this, right? So it's just that I want to introduce you to all this before the time. So say this step-by-step guide on using 6 for Taguchi. The first one is for response methodology. So if you are my project student, please keep this. Very important. Though we still have a run-through later, because we need it. So before you start any experiment, this is the first thing to do. So instead of saying I'm mixing A plus A equals to C, then you, instead of using a strand error, you can start with design of experiment. Let me just tell you, if you want to start your PhD immediately, knowing this is a big tool for you. What?
It's your video.
Prata, continue.
Sorry.
Prata, continue. So, I'm just kidding. So that is that about this. Let me see. So we have seen all these are for Taguchi application is separation process. So that's that about that. Then I want your meeting now, and I want to see what you have done. for your project, for your design project. So let's break into different groups. So I want to see what you have done. Because don't forget, you will defend this. So group 1, group 2, group 3. I want to see what you have done. Come now, group 1, come here. Group 2, come here. I know you've not done anything. That's the reason why you are reluctant. Group 1 here, group 2. Then Ali place group 3. So I will check one by one what you have done. And if there is any problem in your group, I will need to remove that problem now. So please, group 1, group 2, group 3. By now you should have your process design ready. Wait, so how many people do we have online? No one. I think we can leave. I was thinking of taking attendance for them online. So group 1, group 2, group 3. Please hurry up. I want to see what you have done.